Okay, previously I gave you some pointers about how antivirus works and how to get past it. Well, in this day and age, we also have to contend with cloud antivirus products. And here's what a cloud antivirus product does. It checks if an executable is known good, and it does that by looking at its file hash and comparing it to all the things that it's seen from other customers of that vendor. And if it's not, it might send the executable off to the antivirus vendor for analysis, and in the meantime, it'll flag the executable as bad, or at least call the user's attention to it and say, hey, this is a gray executable. I don't know what it is. Only run it with caution. So cloud antivirus is quite a tripping point. I tend to treat cloud antivirus products the same way I would application whitelisting. I don't depend on executables and DLLs as much, and instead I look for other ways to get into memory without using an executable or DLL on disk. Okay, let's talk about Cobalt Strike's Java applet attack. This is a pretty key attack if you have a code signing certificate. First, Cobalt Strike has the applet kit, which is the source code to the Java signed applet attack. By the way, there's also an alternative to the applet kit called the Power Applet, which is an implementation of the applet kit that uses PowerShell to get a payload in memory. So to get the applet kit past antivirus, just download the applet kit, modify and obfuscate it if necessary. If you're going to use the signed applet, I highly recommend that you sign it with your own code signing certificate, build it with the included build script, and then last step, load the included script into Cobalt Strike to make Cobalt Strike use your applet kit over the built-in one. Okay, let's take a look at the applet kit and Cobalt Strike's Java signed applet attack. First, let me show you what Cobalt Strike's Java signed applet attack looks like in the stock version of the tool. Let's go to Attacks, Web Drive-By, Signed Applet Attack, and we're going to stand this up on our internet team server here. We'll call this default. Hit launch, and there we go. There's our applet attack and where it lives. Let's surf over to it on a up-to-date Windows system running the latest version of Java. And what I want you to see is that we're going to get prompted stating that the security settings of Java have blocked our self-signed application from running, okay? There's a lesson here. Ever since January 2014, you cannot use the Java applet attack in production without buying a code signing certificate and signing the attack, the applet attack, with that code signing certificate. So let me show you what I mean by that. Let's hit OK. And what we're going to do to change up the applet attack in Cobalt Strike is go to Help, Arsenal, and download the applet kit. Okay? The applet kit looks like this. It's the source code for Cobalt Strike's applet attacks, and it comes with a build script that actually compiles and builds out the different applet attacks. Previously, I purchased a code signing certificate for me, and I modified this line here, this is the modified line you're seeing, to sign Cobalt Strike's applet kit with the code signing certificate I purchased. Now I have another video where I go through the process of doing that, but I just want you to know what's going on. Now to build the applet kit, just type build.sh, and any changes you made will be taken into account. And there we go. So now, to make Cobalt Strike use our signed applet, signed by downloading the applet kit and bringing in a code signing certificate, let's go to Cobalt Strike scripts, and let's load an aggressor script file. Okay? So we're going to go to the applet folder, and we're going to load applet.cna. Okay? And let's go text, web drive-by signed applet attack, and we'll call this one /awesome, okay? Because this is the applet kit that was signed with our code signing certificate. Let's hit launch, and there we go. There's our new applet attack. Now, let's come over here and surf to /awesome, and you're going to see things are a little bit different. Now, we're being asked if we want to allow the application to run. So let's go ahead and hit run, and if we do, the user has given us a free pass to get code execution on their system. So that's an example of how to use the applet kit with a code signing certificate in Cobalt Strike. Let's talk about the macro attack. For a long time, the macro attack would get past many antivirus products. They just simply weren't looking at it, okay? Around July 2014, many different actors started using the macro in their targeted spear phishing campaigns, okay? And with that came media attention. Many folks in the security trade press were absolutely shocked that the macro could be any risk whatsoever. And they wrote these articles almost laughing about the vector. Anyways, this is a very effective attack, but as of last year, antivirus products have started looking at this vector again. So you may run into a situation where the macro generated by Cobalt Strike is caught by the product in your customer's environment. So you have to deal with that. You can deal with it by obfuscating the code in the macro. All you need to do is just keep changing strings around until it's no longer caught. Okay, let's talk about application whitelisting. What's the defense? Well, the defense is to come up with a list of the applications that the user is allowed to use and not allow anything else to run. So as the attacker, it's our job to get our payload into memory using a whitelisted application. So one option is to use attacks that can inject directly into memory. Cobalt Strike's Java applet attacks do so, okay? The Office macro does so, and the PowerShell one-liners in Cobalt Strike do so as well. For example, the PowerShell web delivery attack. If you want to learn a little bit more about some cutting-edge application whitelisting evasion techniques, I highly recommend you follow Casey Smith, sub-T, on Twitter. This person regularly tweets some very, very interesting things, at least as of the time this course was cut. I also recommend you look at the Whitelist Evasion project on GitHub, as there's some really good stuff there using built-in functionality in Windows to get payloads into memory.